is number 16 in lesson 7.3. We're going to take this region, which is, this curve is y equals sine of x times cosine of x. And we're going to revolve that around the x-axis, and we're going to try to find the volume that's created by that figure. So this is my two-dimensional drawing. So I'm going to take that figure and draw a 3D picture by reflecting that over the x-axis. Try to redraw that a little bit better. Something like that. Okay. So first thing I want you to notice is that there is no space between the axis of rotation and the region. I see no white space in here. The shaded region is along that x-axis that I rated. Okay. So when I rotate it, there's not going to be any hollow space in the middle. When you slice this up, you're not going to get any hollow space in there. You're going to get a solid disc. This would be a solid figure. So if I slice it into circular discs like this, here's the thickness right here. You're going to get a disc. And like this would be the surface of the disc right here. That'd be the circular surface of it. Now, the thickness, the skinny dimension runs sideways. Is that dx or dy? Dx. If it runs sideways, that's dx. So this is a change in x right here. From here to here, that's dx. Your radius would run from here to there. Or, in other words, from here up to here. So to get the radius, you do top curve minus bottom curve. So the top curve is sine of x times cosine of x. The bottom curve, what's another name for the x-axis? Y equals 0. So you'd subtract 0 from that. So that would still get sine of x times cosine of x. So this is going to be the disk method. The disk method is volume equals pi times integral of radius squared. Notice that's just the area of a circle. That's the area of this surface of that disk times its thickness, which is dx. And you're going to integrate from 0 to some b value here. If we're doing everything in terms of x, our bounds also have to be x's. So this will be 0. This will be some value of b right here. So this might be the hardest part, is you have to figure out where does this equation first touch the x-axis. Well, at that point, right there, what's the y-coordinate at that point? 0. So that's the point something 0. So y is 0. So let's put a 0 for y here. So if that equation has to come out, if that expression has to come out to 0, then either sine of x would have to equal 0 or cosine of x would have to equal 0. So let's think about the unit circle and think about where either sine or cosine is 0. Well, right here, right? Which one's 0 right there? Sine. The sine is 0 there. So at 0 radians, the sine is 0. So that would mean that this expression would be 0. So there's our first point, 0, 0. Now as I'm going around the unit circle, where's the next place where either the sine or the cosine would be 0? Pi halves. Yep, right there. At pi halves, the cosine would be 0. And then 0 times anything would give you 0. So this has to be pi halves right here. Now the other way to do that would be to just graph this on your graphing calculator and look for the intersection. Okay? So my upper bound is going to be pi halves. So volume equals pi times the integral from 0 to pi halves. My radius is sine of x times cosine of x squared dx. When you type it in, you're going to also need parentheses right here and here. And you're also probably going to need another set of parentheses here. And out here you have the comma x and all that good stuff. So let's go ahead and type it in and show you what we get here. I'm going to have to erase a little bit of this to get this out of the way here. So I'm going to push math 9, type in left parenthesis, sine of x, cosine of x, and then, I better, another parenthesis, and then squared. and then comma x, comma 0, comma pi halves. So now what else do I have to remember to do at the end of this problem? Times by pi, right. So the answer, you could put 1.96 pi cubic units, or you could hit times pi 0.617 cubic units. It's cubic units because we're doing volume. We're finding the volume. That would be the volume of that figure that's created when you rotate that around the x-axis. Any questions about that?